Devang, for the intro, and thanks everyone for the time today. I'm just going to quickly share my screen. Is my screen showing?
Yes.
Yep. All right. So let me just make sure that I have control here. Okay. Well, today I'm going to mainly tell you about one key barrier that's facing enterprise AI adoption today. And this is really focused on the trade-off that exists between the relevance of outcomes for AI in the enterprise and the costs associated with that. The reason that this has become a crucial trade-off is that as enterprises have started scaling AI POCs to production, they're facing this trade-off that they have to decide between playing it safe and avoiding the use of sensitive data altogether, which obviously loses the relevance of the use case for many of the efficiencies that are important to the enterprise, or to demand dedicated environments, which enables sensitive data use, but comes at high costs and associated poor infra utilization and ultimately lower return on the investment. Now, this trade-off has become this way because the ROI of AI use cases hinges on two things. First is the ability to use sensitive or proprietary data, and then the availability and the costs associated with the compute that's going to run the models. Today, I'm going to tell you about how at Protopia, we've built a product called Stained Glass that eliminates this trade-off, and it unlocks both of these key factors. This enables customers to go from having to manage always on single tenant baseline systems that blow out costs to being able to perform private inference on multi-tenant systems by eliminating plain text exposure and getting 5 to 10 times better cost efficiency with their compute. The critical data privacy gap that has always hindered this in the past is easy to understand in the modern AI application space. Within the enterprise's data owner root of trust on the left-hand side here, data is stored in encrypted form, either on-prem or cloud data platforms, where the prompts are formed or they draw from files within those data platforms. The data is encrypted in transit as well until it gets to the compute backends where the models are running. But when it does arrive at these servers on the right-hand side, ultimately the data is decrypted and it will live in plain text form, both while being processed and even persists on disk with increasing context lengths, logging activities, and so on. At Protopia, our approach to solve this problem has three critical principles that distinguish it from anything else that we know of in the market. There's no requirement for new hardware to procure here, to set up or manage. We are independent of things like trusted execution environments and orthogonal to that. The solution is inference ready with minimal impact on the latency of the inference pipeline. And the third key principle is that we want to enable the use of sensitive data with managed inference platforms that is necessary for scale. So let's talk about how this works. Stained Glass Transform runs within a container at the boundary of the data owner's root of trust. The transformation inputs what is plain text tokens and outputs randomized or stochastic embeddings that can be used as they are with no reverse transformation involved by an unmodified target foundation model. Now, what I'm showing here in the middle is what a reconstruction of those randomized embeddings would look like, but these tokens are not what is being fed to the foundation model, it's the transformed embeddings. Now, I use the word stochastic. These transformations are stochastic in nature, meaning that every time you take the same prompt and go through the transform, the output's going to look different, but all of those different embeddings are going to be understandable by, again, an unmodified target foundation model. Now, why is this even possible? The reason goes back to the fact that these transformations are learned or trained for a given target foundation model. And by construction, the transform requires very little compute to run and runs at this data owner root of trust to unlock much more complex compute infrastructure for the AI application to run on the back end. I mentioned earlier that one of our principal goals here is to enable enterprises to use sensitive data with managed inference platforms. And so what we want is the experience on the left-hand side to be just like you were reaching out to a managed inference platform. So this API on the left-hand side will just be an OpenAI API compatible interface where tokens are fed into this proxy. And this proxy can run within the customer's root of trust because it doesn't require a lot of compute, and can run simply after any sort of runtime firewall or guardrail that the enterprise may have in place. On the right-hand side, what we've done is that we've made it super easy for managed inference platforms to deploy endpoints that can consume these transformed representations. In fact, we've already got a variety of inference platforms like Modal or Base 10 or Amazon Bedrock to enable on either hyperscalers or on a variety of neoclouds the ability to deploy an endpoint that can input such transformed representations. One big recent integration that we've created is with NVIDIA NIMs and NVIDIA AI Enterprise. The NVIDIA AI factory deployment model is something that is increasingly being adopted in regulated industries, government, and sovereign AI. And SGT being integrated with NIMs enables these what are effectively multi-tenant platforms to be able to deliver private inference for the different partners and customers that use each of these NVIDIA AI factories. So if you think about kind of how these are deployed, there's usually one trusted entity like a telco, like Swisscom, or an industry segment leader that will serve many different customers and partner organizations in some locale. And again, with the integration into NIMs that is coming up in an upcoming release, such AI factories will be able to run in multi-tenant but data safe mode. And all of these types of deployments or the entities that run them become essentially market opportunity for Protopia. Now, stained glass as a technology has been built on many years of scientific research. This work started off in University of California, San Diego, in kind of 2017, 2018 timeframe. I collaborated with that team while I was still at NVIDIA. And since then, since the inception of the company, we've kind of pushed the boundaries of what had initially been published, both in the scientific research that we are putting out there, as well as the patent portfolio that we're building. In terms of traction, we have customers both in the enterprise world, as well as Department of Defense and the federal side, and increasingly so in AI application providers, essentially that layer that builds enterprise AI applications for enterprises that are consuming them. One big question that comes up, just very, very low touch on how this technology impacts certain criteria. Whenever we talk about manipulating the prompts themselves in the way that we're talking about, one of the big questions that comes up is, well, what's the impact on accuracy? Or what kind of latency are we talking about here? And so I'm showing here just a very simple snapshot of some benchmarking that's been done across some benchmarks that everyone uses in the industry for Mistral 7B, but similar benchmarking has been done for a variety of Llama models or Qwen or larger Mistral models. And much of this has actually been done in collaboration with the DGX Cloud team at NVIDIA. But what we're showing here is that you can get performance to basically within the noise range of what the original baseline model would have, where now instead of showing plain text, you're operating within the transformations, the transformed representational space that we are feeding into the model without impacting accuracy significantly. And these numbers, it's important to note, are configurable based on how much transformation or noise is being added to the data, which is something that is tuned for the transformation model upon creation. In terms of latency, we're talking about tens of milliseconds of latency compared to seconds of generation time. So generally, this will impact in a very minimal way just the first token, but independent of that, the rest of it is hidden behind the pipeline latency, especially given network communication. As far as the data types that it supports, this is completely independent of both the data type and the model itself, meaning this can work with computer vision models, with streaming video and images. We've done this before, the same way that it does with text and language models that I just talked about. Another important aspect here is that this is complementary to other privacy enhancing technologies, and can be combined often with things like tokenization, things like differential privacy, which are mostly focused on the training side, and trusted execution environments. We can dig into this more with questions. As far as traction goes, we've seen quite a big uptick in our commercialization over the past few quarters. We started the year with very minimal kind of ARR, and we have just gotten into this kind of this quarter, getting close to 300,000 monthly recurring revenue. Year to date, we've booked close to $5 million worth of business, and this is dual use with use cases that mirror between DoD Fed and enterprise use cases in banks or high tech and healthcare. The target for 2026 is something around 10 million ARR. From a team perspective, we come from a variety of backgrounds. Obviously, as Devang was introducing, I spent about a decade at NVIDIA, most of that in NVIDIA research, working on kind of the first iterations of Megatron and parallelization strategies there. We have kind of Brittany, who leads a lot of our marketing efforts, coming from a background of InQtel, as well as Octo, which is now part of NVIDIA. Jennifer comes from a background of in-car security at Toyota, and then prior to that, SolarWinds. And more recently, I won't introduce everyone here, but we have had a senior DoD advisor in Lieutenant General Scott McKean, who's second in command at Army Futures Command, has been working with us for about a year, and we plan on bringing him on full-time as of Q1 26 to lead our Fed efforts. I do want to really, really quickly, in just a minute, talk about one particular type of use case that we see both in DoD and in enterprise that highlights how when we talk about sensitive data, we are not just talking about PII and PHI. This is a lot more than about just regulation. When you think about sensitive data today and how people think about their data as being sensitive or not, something as simple as code is very often considered sensitive, because there's nothing in code that they can point to and say, oh, you should tokenize this variable name, or this is where the IP lies. This is actually quite a difficult problem to solve with existing technologies. And so what we're doing currently with both the Air Force and BugCrowd, which is a customer that's referenceable, they are both looking at the ability to use stained glass to essentially protect different code bases that they want to share the infrastructure that's running things like code analysis, code completion tools on. And this is an example of a use case that's very similar between something like an enterprise use case and what a particular customer in the DoD needs. And we find this to be often the case across a number of our different customers. I'll pause here. There are other kind of examples that I had here to go through, but hopefully they can be reflected in material that we send out. I'll pause here for questions.
Eiman, this is really great. Thanks for sharing. One question off the bat. Actually, Brandon has a question. Brandon, why don't you go first, and I'll go after you.
Yes. Hi, Eiman.
Hey,
nice presentation. Quick question. Anthropic recently put out a white paper on confidential inference. How does this compare to running a model in a secure enclave? I know you mentioned TE earlier, but yeah, how would you compare those? Are they complementary, competitive?
Yeah, so secure enclaves in general, right? Our position on the topic is that the issue with secure enclaves is that they are not widely available. You are essentially trying to solve the problem that the entire industry has by saying, let's just use this hardware that can do something in a very specific way. And that just ends up eating into the principles that we were talking about. We're trying to unlock existing infrastructure to be able to do private compute without leaning into just use this hardware. That's one thing. Second is secure enclaves are about protecting compute structures, right? When I set out kind of laying out the problem at the very beginning, I wanted to highlight that when we're talking about many of these kind of systems on the right-hand side, it's not just that the data is showing up in memory on the right-hand side, but many implementation details result in data often persisting on the right-hand side. And the issue is that the data owner on the left-hand side neither wants to know about every implementation detail, nor can they. And so while trusted execution environments are great, and we can actually use them within how we're setting up these systems, and I can speak to that in more detail, we can complement that, but they're not really going to make this problem go away by themselves. So yes, Anthropic has announced that. There's also been plenty of work done in the confidential computing space over the years. And it's really important to have that capability, to have something where you can do computation in a secure enclave. But it doesn't actually really solve the scale of the problem and the need for being able to do private compute in the enterprise, where a lot of that compute is not capable of doing confidential computing. We can dig into it more, but that's just my first set of kind of answers to the confidential computing side of things.
Thank you.
Thanks, man. Eiman, in this case, let me just put this question real quick. So in this case, you have Llama, Mistral, and other open source models. If you were to support other, if customers wanted to support other models, is it easy enough for them to adopt, or would you need to make some change to the stained glass transformation for them to adopt new models?
Yeah, so real quick, great question, Devang. So real quick is that these transformations are not what we are selling, but they are the artifacts that the platform or the engine that we sell creates, right? So we have built software that runs as an engine to create such transformations. So you can go grab your favorite model off of Hugging Face, have a license to Protopia, and be able to create a transformation for any of those models, right? That also expands to proprietary model providers. Proprietary model providers that already are training those models, they can use our engine to create such a transform for their models, right? We don't provide the services today to go do this for any customer. Again, we're selling the engine, right? And it comes with blueprints of how you can create such transformations. We do partner with entities like, for example, NVIDIA has an AI accelerator business that works with foundation model providers and trains their proprietary models for them, right? So we've been working with that team, showing them, essentially teaching them how stained glass engine works, with the goal that when we take a proprietary model provider that they work with that has interest in stained glass, they can create it for them. So we would not be part of the creation of stained glass for that particular model. They would work with their provider, in this case, AI accelerator out of NVIDIA, to have that created for them. Does that answer the question, Devang?
Yeah, that's helpful. There's one more question, and then I would want to move to the next presentation as well. So Duncan has a question around, am I correct to assume that code base A and B are unable to see each other's enclaves? And could they serve each other in a pipeline? Is there persistence of knowledge between the two?
Yeah, so the goal here is for code. So just to make sure I clarify, the goal here is for users of code base A and code base B to never have either of their code bases appear in plain text on this infrastructure. So this isn't meant to provide cross collaboration between those units. In fact, in this particular example that I'm showing, these code bases are not allowed to appear in plain text on the same infrastructure. So this is actually unlocking them being able to share a compute infrastructure that reduces the cost of even having such a use case. And if they weren't able to do this, it would just be a no-go. In fact, this team has not been using, this team is a team in the Air Force that has not been using language models, specifically because the only way they would be allowed to do so is if they had separate compute infrastructures, and then that becomes too costly and ends up being something that they don't even want to do. And when I'm talking about too costly, this is not that the Air Force does not have money to spend. It is that this is a problem of scale, right? You have many, many instances of such teams where they need to be able to do something privately, but standing up a allocation of H100s that they can use both efficiently from a interactivity perspective and still have that maintained just wouldn't make sense for each unit, right? And so hopefully, Duncan, I'm trying to communicate here that this is about the infrastructure on the right-hand side not having any exposure, and each of the units being able to independently operate without there being any cross correlation between the tenancies. Sasha is also asking a real question. Is there a specific ask by Protopia raising target amount what stage? So thank you for asking that question. I'll really quickly say we do have a little bit of room in our current Series A round. So happy to chat about that if there's interest in participating in that. We're looking at our Series B round somewhere in the kind of Q2 to Q3 of next year is where we would go to market for that. But right now, yes, we do have some availability in the range of about 3 million, 3 to 4 million is something that we do have availability right now.
That's great.
And I'm happy to provide details offline as well.
Yep, and I'll send the materials, and then if there's more interest from this group, I'll consolidate that and bring that back to you. Well, great, Eiman, thank you again, and fantastic. Excited to see the journey. Yep.